Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming.
A recent discovery has captivated the imagination of scientists and space fans everywhere. The excitement began when Bill Nye, a famous science communicator, shared some incredible news. Voyager 1, the spacecraft that's been exploring the outer edges of our solar system, had picked up evidence of alien life far out in space. What could this find reveal about our universe? How might it impact our view of the cosmos? Join us as we delve into the details of Bill Nye's revelation. Voyager 1 has made a terrifying discovery after 45 years in space, unveiling the solar system's secrets. For almost 5 decades, the Voyager missions have given us some of the earliest and most incredible views of our solar system's wonders. What's truly surprising is that these missions weren't designed to last this long. In the 1970s, a scientist named Michael Minovich came up with a groundbreaking idea. Spacecraft could use the gravity of planets to push themselves even farther into space. This concept changed everything. Though Voyager missions were originally meant to last only 5 years, they have far outlived that expectation. Launched in the summer of 1977, Voyager 1 and Voyager 2 were initially tasked with exploring Jupiter and Saturn. They succeeded in their mission, providing valuable insights into these giant gas planets. But their adventure didn't stop there. Voyager 2 went on to make history by performing the first close-up flybys of Uranus in 1986 and Neptune in 1989. These incredible journeys earned the mission the nickname Voyager Grand Tour. Instead of wrapping up after these accomplishments, the resilient spacecraft aimed even higher, venturing into the uncharted depths of space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, gathering important data from the far edges of our solar system. In a major milestone announced in 2013, NASA revealed that Voyager 1 had officially entered interstellar space. This region, beyond the reach of our sun's influence, is like stepping from a bustling city into a quiet, star-filled wilderness. The journey continued in 2018, when Voyager 2 also crossed into this vast region, around 11 billion miles from the sun. Remarkably, Voyager 1 and Voyager 2 are the only spacecraft to have reached interstellar space, and they are now studying how this distant region interacts with the solar wind from our sun. NASA's Voyager 1 and Voyager 2 spacecraft have given us incredible insights into the heliosphere. The heliosphere is a vast, bubble-like region surrounding the sun and its planets, created by the constant flow of charged particles known as the solar wind. This bubble extends far beyond the orbit of Pluto and acts as a shield against the radiation and cosmic rays from outside our solar system. NASA studies the heliosphere to understand the fundamental physics of our space environment and to gain insights into how space affects the habitability of planets. The solar wind is made up of charged particles, or plasma, which has its own set of physical rules, different from solids, liquids, and gases. As this plasma flows outward from the sun, it creates an environment filled with radiation and magnetic fields that stretch back to the sun. This environment is further influenced by cosmic rays from outside the solar system and occasional bursts of solar material known as coronal mass ejections. The heliosphere plays a crucial role in protecting the planets, including Earth, from harmful radiation from deep space. Earth's magnetic field, called the magnetosphere, adds another layer of protection, shielding us from both solar and cosmic radiation and preventing the solar wind from eroding our atmosphere. Planets without such a magnetic shield, like Mars and Venus, face different challenges as a result. NASA's research on the heliosphere covers several important topics: how the solar wind behaves near Earth, the origins and maintenance of magnetic and electric fields around other planets, the interaction between the heliosphere and the interstellar medium, the appearance of the heliosphere's boundaries, the evolution of solar wind and cosmic rays, and what factors contribute to making exoplanets potentially habitable. Recently, scientists made an exciting discovery. Voyager 1 detected a low humming noise that matched vibrations in the sparse gas found in the vastness of interstellar space. Nicola Fox, who leads NASA's heliophysics team, emphasized the groundbreaking nature of these missions. She pointed out that for 46 years, the Voyager spacecraft have greatly enhanced our understanding of the Sun and its impact in ways no other missions have achieved. It's an extraordinary journey through the cosmos. The Voyager spacecraft operate using a power source based on plutonium. Plutonium is a unique and intriguing element. This actinide metal is silver gray and has a shiny surface when freshly exposed. Plutonium is quite versatile, existing in 6 different forms, or allotropes, and can show up in 4 different chemical states, or oxidation states. It has interesting reactions with various elements and compounds, including carbon, halogens, nitrogen, silicon, and hydrogen. When plutonium comes into contact with moist air, it reacts to form oxides and hydrides. Over time, plutonium generates less heat, causing the spacecraft to gradually lose power. In response, NASA had to make some tough decisions. They decided to turn off non-essential systems and even some that were initially considered crucial. For example, the heaters meant to keep the spacecraft's instruments warm in the extreme cold of space were shut down. Here's the remarkable part. Despite these difficulties, all 5 of the scientific instruments aboard the Voyagers have continued to function flawlessly since 2019. This unexpected endurance has left NASA experts puzzled as they try to understand how these spacecraft are still operating in conditions that would usually freeze other machines. This ongoing mystery adds to the awe-inspiring legacy of these pioneering spacecraft. The mysteries of the shifting Heliopause. Astronomers are encountering surprises at the far reaches of our solar system. The Heliopause, the boundary where the Sun's influence ends and interstellar space begins, isn't remaining constant. Instead, it's shifting and creating unusual angles, which has left scientists both astonished and puzzled. This notion of a moving heliopause isn't new. Over the last decade, data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer, IBEX, satellite, have revealed that the heliopause is not fixed, but changes over time. These spacecraft are invaluable because they provide direct measurements of this cosmic frontier, though they capture only specific points in space and time. Dr. Eric J. Zarin, a space physicist at Princeton University, explained that IBEX is offering additional insights that are helping scientists refine their predictions about the heliopause's behavior. What's particularly fascinating is that recent findings have challenged our previous understanding. In 2014, IBEX detected an unusual surge in energetic particles, hinting at irregularities in the heliopause that didn't fit with established models, like an unexpected twist in a story. Furthermore, data from Voyager 1 and Voyager 2 revealed significant shifts in the position of the heliopause in short periods. This could explain why these spacecraft entered interstellar space in 2012 and 2018 with a substantial gap in between. These surprising developments challenge what we thought we knew about heliopause and have been described as entry-speaking in a recent Nature Astronomy article, indicating they are perplexing and may provoke debate among scientists. The search for answers is ongoing. Scientists are eagerly anticipating the launch of NASA's Interstellar Mapping and Acceleration Probe in 2025, which is expected to provide further insights into the enigmatic regions at the edge of our solar system. Until then, the mysteries of heliopause and beyond continue to captivate our curiosity. In May 2023, Voyager 1 faced a puzzling situation during its routine operations. The part of the spacecraft responsible for managing its high-gain antenna, called the Attitude Articulation and Control System, AACS, began sending back odd and unclear information. Instead of the usual updates about the spacecraft's health and status, it was as if Voyager 1 was struggling to communicate properly, almost like having electronic aphasia, where words don't come out right. From Earth's perspective, it looked like Voyager 1 was having technical trouble, with the data it sent back appearing random or disjointed. Despite these strange reports, Voyager 1 seemed to be functioning normally. Its radio signal was strong and steady, showing that the antenna was still correctly pointed at Earth, contrary to the confusing data from the AACS. Even more intriguingly, Voyager 1's scientific instruments continued working perfectly, oblivious to the AACS issues. The spacecraft's fault protection system, which is supposed to put it into safe mode during problems, did not activate. Luckily, NASA soon figured out that the issue was caused by the AACS using an old, inactive computer. The fix seemed straightforward. Just tell the system to switch to the working computer to handle the data transmission. But the big question still lingered. Why did the AACS start acting up in the first place? NASA thought that maybe a wrong command from another onboard computer might have caused the glitch. Although this hiccup didn't put Voyager 1's safety in danger, NASA is digging into what happened to make sure it doesn't happen again. A journey beyond the sun's shield. Voyager 1 has been traveling through the vastness of space beyond the sun's protective magnetic shield for over a decade. This shield, like Earth's own magnetic field, acts as a protective barrier against cosmic rays and space radiation, keeping the spacecraft safe. Just as high-energy particles on Earth can affect our computers, they also impact Voyager 1's computers, causing small glitches in their memory that build up over time. Susan Dodd, the project manager for both Voyager 1 and Voyager 2, sheds light on these challenges. She notes that dealing with such issues is normal at this stage of their mission. The Voyagers have been on an incredible journey for nearly 50 years, far surpassing their expected lifespan. They are now exploring interstellar space. Put simply, interstellar space is the vast region that stretches between stars, but it's far from being empty. This space is filled with a mix of fascinating stuff: neutrinos, charged particles, atoms, molecules, dark matter, and photons. These photons range from the most energetic radiation to the faint light of the cosmic microwave background, CMB, though they're spread out quite thinly. The National Radio Astronomy Observatory tells us that, on average, stars in our Milky Way galaxy are about 5 light-years apart. However, they are clustered more closely together near the galaxy's center compared to the edges where our Sun and Earth are located. This means there's a lot of space between the stars. Everything in this vast expanse is called the interstellar medium, or ISM for short. Since their launch nearly half a century ago, Voyager 1 and Voyager 2 have covered immense distances, exploring new areas and making significant discoveries. They now face a special challenge. Their computers, designed in the 1970s, have just 70 kilobytes of memory. To put that in perspective, that's only a tiny fraction of what even modern digital watches use. Despite these limitations, NASA has managed to keep the spacecraft running smoothly. Just imagine the effort it takes to send updates across such vast distances. It's like cosmic IT support. So as the Voyager probes continue their journey, billions of miles from Earth, they've achieved major milestones and provided us with invaluable insights into our solar system. Let's celebrate these remarkable spacecraft. They are now leaving our solar system and drifting among the stars. Each Voyager is about the size of a small car. Even though their technology seems outdated compared to today's gadgets and their cameras may look primitive, they have made a lasting mark on our understanding of space. Voyager 1's grand adventure. The Voyager spacecraft provided us with remarkable insights into Jupiter. This enormous planet is far from being a calm giant. It is a world of extremes. Jupiter features hundreds of intense hurricanes, a dazzling aurora at its north pole, and 3 delicate rings with a complexity surpassing that of a finely woven tapestry. Saturn also revealed surprises. Its rings, once thought to be simple, are actually made up of thousands of tiny ringlets that form intricate patterns, defying earlier predictions by experts. Even more astonishing were the discoveries of active volcanoes on Jupiter's moon Io and Neptune's moon Triton, volcanoes previously believed to be unique to Earth. On Triton, nitrogen geysers erupt at temperatures extremely close to absolute zero, an incredibly cold environment. The most exciting find was the possibility of alien life. 2 of Jupiter's moons, Europa, and Saturn's moon Enceladus, seem to have vast, salty oceans hidden beneath their icy crusts. These oceans could potentially support life, making these moons prime targets for future exploration. As Voyager concluded its mission, it left behind a touching image of our solar system, including Earth. In the early 1990s, an image famously known as the pale blue dot was captured following Carl Sagan's idea. Inspired by the Earthrise photos from Apollo missions, Sagan wanted to show Earth from a distance 100,000 times farther away. This image offered a new perspective, helping us appreciate our place in the vast expanse of the universe, a view never before seen. On August 25, 2012, Voyager 1 achieved a historic milestone by crossing into the vast expanse of interstellar space, an astonishing 11 billion miles from the Sun. Despite being so far away, Voyager 1 continues to send us valuable data. Its sibling, Voyager 2, joined the interstellar voyage in 2018. These groundbreaking spacecraft are now so distant that it takes about 22 hours and a half for a radio signal traveling at the speed of light to reach Voyager 1 from Earth, and nearly 19 hours for Voyager 2. Every day, these adventurous probes drift an additional 3 to 4 light seconds farther away. NASA's Deep Space Network maintains crucial contact with these distant spacecraft. The Deep Space Network, or DSN, is NASA's global network of massive radio antennas that helps with spacecraft missions far from Earth and those that stay closer to our planet. This impressive setup also supports radar and radio astronomy to boost our knowledge of the solar system and beyond. Managed by NASA's Jet Propulsion Laboratory, which oversees many of NASA's robotic space missions, the DSN is essential for exploring the cosmos. It operates 3 major facilities strategically placed around the globe. These are located in Goldstone, California, near Madrid, Spain, and close to Canberra, Australia. They are spaced about 120 degrees apart in longitude, ensuring that as Earth rotates, at least one site can always stay in touch with spacecraft. This setup means that if a spacecraft moves out of reach of one site, another can continue the communication without interruption. The antennas of the DSN are crucial for exploring deep space. They allow us to send commands to our spacecraft and receive their groundbreaking images and scientific data, which enhances our understanding of the universe, the solar system, and our place within it. The DSN isn't just a collection of large antennas. It's a vital system for controlling, tracking, and ensuring the safety of spacecraft exploring distant planets. It also supports important scientific research, such as studying asteroids and the interiors of planets and moons. Each DSN site features multiple large antennas and sophisticated receiving equipment that can pick up very weak signals from far-off spacecraft, ensuring continuous communication and data collection from the Voyagers and other missions. Now it's time for today's subscriber pick. In a hushed auditorium filled with eager scientists and enthusiasts, Bill Nye stepped up to the podium, his expression a mix of excitement and gravity. "Ladies and gentlemen," he began, "Voyager 1 has made a terrifying discovery after 44 years in space." The crowd leaned in, hanging on his every word. Voyager 1, humanity's farthest-reaching probe, had been sending back data from the edge of the solar system. Most of it was routine until a month ago, when an anomalous signal caught the attention of Mission Control. Nye revealed that the spacecraft had detected a massive structure just beyond the Heliopause. This structure wasn't natural. It was an enormous, seemingly artificial object, and it was moving. Grainy images appeared on the screen behind him, showing a colossal ring-like formation drifting through the cosmic expanse. Its surface was covered in unfamiliar symbols and intricate patterns, suggesting it could be a form of spacecraft or habitat. Its erratic trajectory implied it was searching for something or someone. The room filled with murmurs. This could be evidence of extraterrestrial life, indicating humanity was on the brink of first contact. Nye explained that international space agencies were working together to decipher the symbols and understand the object's purpose. This discovery challenged everything known about our place in the universe. The audience buzzed with excitement and curiosity. Voyager 1 had opened a new chapter in human exploration, filled with the thrilling uncertainty of what lies beyond. Humanity's greatest leap into space. The Voyager mission is considered one of humanity's greatest scientific achievements, a massive effort equivalent to around 10,000 years of work. Remarkably, this mission almost didn't happen. The Voyager project was a lucky break in space travel. Michael Minovich first discovered that spacecraft could use a planet's gravity to boost their speed and travel farther from the sun. Building on this idea, Gary Flandreau showed that spacecraft launched in the late 70s and 80s could take advantage of a special alignment of outer planets to speed up their journey. This discovery made it possible to reach Neptune at the edge of the solar system in just 12 years instead of the expected 30. NASA seized this chance, but budget limits meant they had to scale back their original plan. Instead of a grand tour, they chose a more budget-friendly visit to Jupiter and Saturn, which still cost $250 million. Researchers hoped that if Voyager 1 succeeded at Jupiter and Saturn, they could adjust Voyager 2's path to explore Uranus and Neptune. The twin Voyager spacecraft, launched by NASA, were equipped with a range of cutting-edge tools. These included cameras, spectrometers for detecting infrared and ultraviolet light, sensors for mapping cosmic particles like charged particles and cosmic rays, and even a photopolarimeter and a magnetometer, all powered by nuclear energy. Their journey has become legendary, not just a scientific mission, but a captivating adventure that blends mythology and science. The stunning images of distant worlds taken by these spacecraft turned the Voyager mission into a groundbreaking exploration of the unknown. A particularly remarkable feature of the Voyager mission is the golden record. Each spacecraft carried a phonograph record packed with images, music, and sounds from Earth, including greetings in 55 different languages. This golden record was like a cosmic message, meant to reach any intelligent beings out there in the Milky Way. A hopeful attempt to communicate across the vast distances of space. The idea of alien civilizations finding these records is thrilling, as it hints at the possibility of recognition beyond our world and a form of cosmic immortality. The Voyager mission stands as a testament to our deep curiosity about the universe, reflecting our collective wish to understand our place in the cosmos. For over a decade, these twin spacecraft have allowed us to explore the space between the stars. The data sent back by the Voyagers has not only given us invaluable insights into our solar system, but also revealed surprising and unusual details about the space beyond our sun. Thanks to the Voyager spacecraft, we now know the heliosphere extends a staggering 11 billion miles from the sun. It surrounds the sun, all 8 planets, and many distant objects, serving as a shield that protects everything within it, including our own DNA, from the intense radiation of the galaxy. Imagine the heliosphere as a giant protective shield, guarding our solar system from the vast, empty stretches of space between the stars. To unravel the mysteries of this cosmic barrier, we need to understand the heliosphere completely. That's where NASA comes in, acting like cosmic tech support. They make sure our far-off spacecraft, like the Voyager probes, stay in good working order by sending them software updates across incredible distances. It's a bit like performing surgery on a patient that's 15 billion miles away, definitely not a typical Monday morning task. Updating Voyager's software is no easy feat. It involves sending new instructions straight to the spacecraft's computers, which understand only the most basic language known as machine code. This means the instructions must be written in a way that the hardware can interpret without the aid of an operating system or fancy programming tools. To tackle this challenge, NASA engineers blend creativity with resourcefulness. They use assembly language, a coding language close to machine code, to write these updates. This method gives them precise control over the spacecraft's hardware, ensuring the code runs as smoothly as possible. They also use pseudocode, which simplifies commands to handle repetitive tasks efficiently without using too much memory. These software updates are vital for keeping our brave spacecraft alive. Over time, they have fixed various issues, from malfunctioning parts to memory problems. For example, one update once saved Voyager 1 from a serious issue when a hardware component failed. The update triggered a backup system that helped the spacecraft continue its journey through space. The Voyager missions were far from ordinary. They were the beginning of many thrilling interstellar adventures. These missions made groundbreaking discoveries and sparked further exploration of the cosmos. When Voyager took a closer look at Jupiter, it revealed the planet's fascinating details. This discovery thrilled NASA and led to the launch of two major missions, Galileo in 1989 and Juno in 2011. In many ways, Voyager was the trailblazer for these significant space explorations. But that's just the beginning. The groundbreaking work of the Voyager spacecraft set the stage for the famous Cassini mission to Saturn. Jonathan Lunine, a leading planetary scientist at Cornell University, points to Voyager 1's close-up flyby of Titan, one of Saturn's moons, as a major influence on the Cassini mission's success. In fact, Cassini went on to land a probe called Huygens on Titan's surface in 2005, where it captured breathtaking video footage. Voyager 2 also played a crucial role. It sparked interest in studying the icy giant planets, not just in our own solar system, but also in far-off star systems. Imagine this. Many of the exoplanets we've discovered so far are similar in size to Neptune and Uranus, thanks in part to Voyager 2's contributions to our understanding of these distant worlds. Now, let's look at what's happening today. NASA is building on Voyager's legacy with exciting new missions. The Dragonfly mission is set to land on Titan, Saturn's largest moon, in 2034. Meanwhile, the Europa Clipper mission will start exploring Jupiter's moon Europa, first seen by Voyager, in 2030. Additionally, the National Academy's Planetary Science Survey has proposed a $4.2 billion mission to Uranus, including an orbiter and probe, scheduled for the 2040s. This mission aims to deeply explore Uranus and its moons, continuing the journey that Voyager 2 began with its brief visit to the Uranus system in January 1986. The Voyager's unending journey. It's been almost 50 years since Voyager 1 and Voyager 2 set off on their amazing adventure through space, yet their influence remains strong. These spacecraft sparked a wave of curiosity and discovery that keeps unfolding. Here's the latest. Both Voyager 1 and Voyager 2 are still in touch with NASA's Deep Space Network. This network, originally designed to communicate with Voyager 2 during its missions to Uranus and Neptune, is still sending and receiving data from Earth. This ongoing connection is truly incredible. Ed Stone, the chief scientist for the Voyager missions, shared these updates at a recent news conference. He mentioned that NASA is still gathering important information from the Voyager spacecraft, and the plan is to keep this interstellar exploration going for another 5 or 6 years. However, by the mid to late 2020s, the scientific instruments on the spacecraft will be turned off, and they will become silent and inactive. Even so, their journey into the vast unknown of space will continue forever. Stone, who is now in his 80s, jokingly said he hopes to outlive the Voyagers, though he's not sure if that will happen. In about 300 years, both Voyager 1 and Voyager 2 will enter the Oort cloud. The Oort cloud is a fascinating and mysterious region theorized to surround our sun with countless icy bodies. These icy planetesimals are thought to stretch from 1,000 to 200,000 astronomical units away from the sun. To give you a sense of this vast distance, it ranges from 0.03 to 3.2 light-years. The concept was first introduced in 1950s by a Dutch astronomer named Jan Oort, who suggested that this cloud continuously supplies our solar system with long-period comets. These comets make their way into the inner solar system, where they often meet their fiery end as they get too close to the sun. The Oort cloud is believed to have two distinct parts. The first part is the inner Oort cloud, which is disc-shaped and aligns with the plane of our solar system, also known as the Hills cloud. The second part is the outer Oort cloud, which forms a spherical shell surrounding the entire solar system. Both parts of the Oort cloud lie far beyond the heliosphere, the bubble-like region of space dominated by the solar wind, and extend into interstellar space. After another 30,000 years, Voyager 1 and Voyager 2 will leave our solar system and start orbiting the center of the Milky Way for millions of years. Even though their main missions will end, their amazing journey through space is just beginning. While the Voyagers continue their adventure, NASA's Hubble Space Telescope, which has been studying the universe for almost 33 years, keeps making incredible discoveries. Recently, Hubble took a picture of a distant spiral galaxy called MCG plus 0124014, located about 275 million light-years away. This galaxy is unique because it has 2 spiral arms and a bright core. It is a Type II Seyfert galaxy, known for its bright centers that are not as intense as quasars. It's like a cosmic performance where galaxies reveal their secrets, helping us learn more about the universe. What makes this galaxy special is its unusual light. Normally, the light patterns from atoms and molecules follow certain rules, but in space there are lines in these patterns called forbidden emissions that break the rules. It's like they're rebelling. These emissions are called forbidden because on Earth they are so unlikely that we don't usually see them. However, in the active center of a galaxy, things are different. This forbidden light becomes visible, and that's what the Hubble telescope captured. The photo, taken by Hubble's advanced camera, shows MCG plus 0124014 shining brightly. There are also 2 bright stars in the foreground, one blue and one red, adding extra sparkle. What do you think about the Voyager's journey so far? Let us know your opinion in the comments below.